One of the brightest stars in the night sky may be far more mysterious than it appears. High above us, in the constellation Orion, there is a huge reddish star known as Betelgeuse. You can see it without a telescope on a clear night, appearing like an orange-red point on Orion's shoulder. Humans have watched this star for centuries, but modern astronomy has revealed that there is much more happening there than anyone once imagined. Betelgeuse is a red supergiant, and its size is almost impossible to picture. If it replaced our Sun at the center of the solar system, its enormous outer layers would extend far beyond the inner planets and reach toward the region of the outer solar system. But size is not the only reason scientists are fascinated by it. Betelgeuse is approaching the final stages of its life. Massive stars eventually exhaust their nuclear fuel, and when the balance inside the star fails, the core can collapse and trigger a powerful supernova. That does not mean Betelgeuse is about to explode tomorrow. Astronomers still cannot predict the exact timing. The event could be thousands of years away, or much longer. But the star is already showing unusual behavior. The biggest mystery appeared in late 2019. Betelgeuse suddenly became much dimmer than normal. Over several months, its brightness dropped dramatically, making the normally prominent star look surprisingly faint. The change was so unusual that people began wondering whether they were witnessing the beginning of a supernova. Astronomers immediately started investigating. Telescopes around the world turned toward Orion. Researchers proposed different explanations. Maybe a huge region on the surface had cooled. Maybe the star's normal pulsation had changed. Or perhaps something much more dramatic was happening deep inside. Then the star began brightening again. By 2020, Betelgeuse was recovering. So what had happened? Scientists eventually found evidence that a tremendous amount of material had erupted from the star's surface. Betelgeuse is not a calm sphere. Its outer layers are constantly moving. Enormous bubbles of extremely hot gas rise from deeper inside, reach the surface, and then cool. During the unusual event, one of these massive convective regions appears to have produced a gigantic eruption. Material was thrown outward from the star. As it traveled away and cooled, some of that material formed dust. From Earth, the dust moved across part of Betelgeuse's visible surface. It acted almost like a giant curtain, blocking some of the light coming from behind it. So the star had not suddenly stopped shining. We simply could not see as much of its light. The event gave astronomers an extraordinary glimpse into how violently a red supergiant can behave. But there was another mystery hiding in the data. For decades, scientists had noticed that Betelgeuse's brightness changes followed certain patterns. One variation happens roughly every year, as the enormous star expands and contracts. But researchers also noticed a much longer cycle that was harder to explain. That raised an intriguing possibility. Maybe Betelgeuse was not alone. If another star were orbiting nearby, its gravity could disturb the enormous atmosphere surrounding Betelgeuse. It might also influence the dust around the star and change how bright Betelgeuse appears from Earth. The problem was finding it. Betelgeuse is incredibly bright. Trying to detect a faint companion beside it would be like trying to spot a tiny flashlight next to an enormous searchlight. Astronomers searched for decades, but the companion remained hidden. Then researchers used long-term observations and orbital calculations to predict where such a companion should appear if it really existed. In 2024, the predicted position became especially favorable. Powerful telescopes were aimed at Betelgeuse, and astronomers carefully processed the observations to remove the overwhelming glare of the giant star. And then something appeared. A faint source of light was detected close to Betelgeuse, in the region where the models had predicted a companion might be. After generations of speculation, astronomers finally had evidence of another star hiding beside one of the most famous stars in the sky. And the discovery created an even bigger question. If this companion is really orbiting Betelgeuse, could its gravity be influencing the giant star? Could it help explain the mysterious brightness cycles? Could it disturb the enormous clouds of gas surrounding Betelgeuse? And perhaps most importantly, could it have played some role in the strange eruption that caused the Great Dimming of 2019? Scientists do not yet have a definitive answer. But now they have something they did not have before, another piece of the puzzle. And this is where the story becomes even more fascinating, because modern telescopes are allowing astronomers to study Betelgeuse in wavelengths of light that human eyes cannot see. The James Webb Space Telescope can observe infrared radiation, allowing researchers to investigate dust, gas, and structures surrounding the star that are difficult to study in ordinary visible light. What Webb and other powerful instruments reveal is a star that is anything but peaceful. Its surface is constantly boiling and changing. The discovery of a possible companion changes the story of Betelgeuse in a major way. For years, astronomers had tried to explain why the star's brightness followed more than one repeating pattern. Now, the presence of another object nearby provides a possible explanation. A companion moving around a giant star can influence the material surrounding it. Its gravity can disturb gas, shift dust, and potentially create a trail through the outer atmosphere. Imagine a boat traveling through water. As it moves, the water behind it becomes disturbed and forms a wake. Something similar could happen when a smaller star moves through the enormous atmosphere of Betelgeuse. The companion may create a wake of disturbed gas as it travels through the outer layers. If that interaction is confirmed, it could help explain some of the unusual structures astronomers have observed around Betelgeuse. But there is still a much bigger question. Could this hidden companion have anything to do with the dramatic dimming that occurred in 2019? The answer is not known. Scientists have not established that the companion triggered the eruption. However, its gravitational influence gives researchers another possibility to investigate. Betelgeuse already contains enormous movements of gas beneath its surface. Giant convection cells carry energy upward, while the star constantly loses material into space. A gravitational disturbance could potentially affect that unstable environment. Whether that happened during the Great Dimming remains an open question. This is exactly why observations from the James Webb Space Telescope are so important. Webb can observe infrared light, which allows astronomers to study parts of Betelgeuse that are difficult to see through ordinary visible light. Dust is especially important. The same dust that can block visible light may be much easier to investigate using infrared observations. That means Webb can examine the clouds surrounding Betelgeuse and learn more about what the star has been throwing into space. The telescope can also study the temperature and movement of material around the star. And what researchers see is an environment in constant motion. Betelgeuse does not have a smooth, quiet surface. Instead, enormous regions of hot plasma rise from below, reach the surface, cool down, and sink again. Some of these structures are incredibly large. The entire surface behaves more like a constantly moving ocean of plasma than a solid sphere. Material is continually being pushed outward. Some of it eventually becomes dust. Some of that dust remains around the star, creating shells and clouds that preserve evidence of earlier eruptions. These structures are extremely valuable to astronomers because they act like a historical record. By studying the material surrounding Betelgeuse, researchers can learn about events that happened long before modern telescopes existed. In a sense, the space around the star contains memories of its past. And those memories may help scientists understand what comes next. Eventually, Betelgeuse will reach the end of its stellar life. A massive star cannot continue producing energy forever. As its fuel changes, the internal balance becomes increasingly difficult to maintain. Eventually, gravity can overcome the pressure supporting the core. When that happens, the core collapses extremely rapidly. The outer layers then respond to this catastrophic change, producing a supernova. From Earth, it would be an extraordinary sight. Betelgeuse could suddenly become far brighter than it is today. It could be visible during daylight. At night, its brightness could become a remarkable feature of the sky. People across the world would be able to observe it without specialized equipment. But there is one important detail. We do not know when this will happen. Betelgeuse could explode thousands of years from now. It could take much longer. Astronomers cannot currently give us a precise date. And because Betelgeuse is hundreds of light-years away, there is another fascinating complication. The light we see from the star today began its journey centuries ago. When we look at Betelgeuse, we are seeing an earlier version of the star. If something dramatic happened there today, Earth would not see it immediately. The information would need to travel across space at the speed of light. So the supernova could technically already have happened from Betelgeuse's point of view, while we continue seeing the star as it was centuries ago. That is one of the strangest realities of observing the universe. Distance creates a delay between an event and our knowledge of it. For centuries, humans have looked toward Orion without knowing what was happening on that distant giant. Ancient observers saw the same reddish star. Later generations built telescopes and discovered that it was enormous. Then increasingly advanced instruments revealed its changing surface, its surrounding dust, and the tremendous amount of material it has lost over time. Now astronomers may have identified a hidden companion. Modern infrared telescopes are also allowing them to investigate the star in unprecedented detail. Every new observation adds another piece to the puzzle. And Betelgeuse is teaching scientists something important about massive stars. Their final stages are not necessarily quiet. A star can undergo enormous eruptions, lose tremendous amounts of material, interact with another object, and dramatically change its appearance